All right, if you would please find your proportional versus non-proportional worksheet. We are going to go through this together. All right, so letter A, linear relationships are either proportional or non-proportional. Below is one example of each. So I have an example of teacups, and then I have an example of paper cups. All right, so for my teacups, I want to know the process of how I go from one teacup to the height. So for one teacup, my height is 4. So I'm going to say I'm going to multiply by 4. Okay, so if I have 2 teacups, so I have 1 teacup here, that's a height of 4. For 2 teacups, my height is 8. So I go from 2 to 8, and it looks like I can multiply it by 4. 3 teacups to 12 inches, well, 3 times 4 is 12. 4 times 4 is 16. And then 5 times 4 is 20. Okay? All right, let's see. Now I have my paper cups. All right, so for 1 cup, it's the height of 6 inches. Okay, so I can multiply by 6. Okay, or I can add by 6. For 2 cups, it's 8 inches. 3 cups, it's 10 inches. 4 cups, it's 12 inches. 5 cups, it's 14 inches. Now notice right here, every time I'm going up by 2, 2, 2, 2. For here, I'm going up by 1, 1, 1, 1. Okay, so if let's say I can take 1 and I'll multiply it by 2. Okay, well, I've got 1 plus 2, or 1 times 2 is 2. I now need to add 4 to get to 6. Okay, let's see if this works for here. Well, 2 times 2 is 4. If I add 4 more, am I going to get to 8? Okay, that seems about right. 3 times 2 gets me 6. Well, is 6 plus 4 equal to 10? 4 times 2, which is 8, plus 4 is 12. And then 5 times 2, which is 10, plus 4 is 14. You're probably saying, Ms. Roberts, how do I get to times 2? Well, what I did here is I said, what is the difference between 6 and 8? And that's 2. Difference between 8 and 10 is 2. 10 and 12 is 2. So I'm skipping 2 every time. I'm skipping 1 every time. So when I look at this, I'm going to have the difference of 2 over the difference of 1, which is 2. Okay? Meaning that my rate is going up by 2 each time. Now, when I did 1 times 2, I got 2. I still have to make up the difference to get to 6, and I added 4. Okay, I wanted to see if this process is going to work for every one of them. 2 times 2 is 4 plus 4, which gets me 8. 3 times 2, which is 6 plus 4, which gets me 10. When looking at this, you have to think about the difference. So, looking at our teacups, okay, of why I have to add a number here versus here. If I look at the teacups, I see my saucer and I see my cup. Every time I add a new teacup, I'm adding a new saucer in between my teacups. So I've got a saucer, teacup, saucer, teacup, saucer, teacup, saucer, teacup, saucer, teacup. Okay? When you have your solo cup, so like think of red solo cups. When you put your cups one inside the other, they stack nice and neatly. Okay? So this plus 4 is this right here. This plus 4 is the portion of the height of the original cup. Okay? And then this times 2 is just this little bitty extra right here. So I've already started at a height of 4, and then I need to keep going up and up and up. Whereas here, I started with the height of 0. I started at the bottom, okay? And then I multiplied as I continued going up. For here, I had to start with a specific height, and then I multiplied by 2 each time to go up, okay? So examine the rate of change between number of cups and height. As the number of cups increases by 1, the height of my stack increases by 4. Okay? As the number of cups increases by 1, so as I increase the number of cups by 1, the height of my stack, it is increasing by 2. Okay? So if you multiply the number of cups by the rate of change, do you get the height of this stack? So look, if I did 4 times 1, do I get 4? Yes. 4 times 2, I get 8. 4 times 3, I get 12. 4 times 4, I get 16. And 4 times 5, I get 20. So yes, I get the height each individual time. Okay. As the number of cups increases by 1, the height is 2. Okay. So I increase my height of 2. Well, 1 times 2, that gets me 2. That does not get me to 6. I have to add 4 more to get to 6. 2 times 2, 4. Well, I have to add 4 more to get to 8. And the same process all the way through. I have to add 4 each time to my height. So I do 4 times 2, which is 8, plus 4, which is 12. And then the last one, 5 times 2, which is 10, plus 4, which is 14. Okay. Sketching my graph. The number of cups is our x. The height is our y. So if I had 0 cups, so 0 times 4 is equal to 4. Or is equal to 0. Sorry. I'm going to start at 0. At the height of 2 cups, I'm at a height of 8 inches. 4 cups, I'm at the height of 16. Okay. 6 cups, well, 6 times 4 is 24. So 5 times 4 is 20. And right here. So what do you notice? Did I do my numbers in the wrong spot? No, I did them in a good spot. What do you notice about this right here? Okay, straight line going up. Okay, well, let's try this one. So wait, if I plug in 0 into my spot, so I do 0 times 2, which is 0, and I add 4 to it, where do you think I'm going to start? I'm not going to start at 0. I'm going to start at 4. Well, 2 cups gives me the height of 8. 4 cups gives me the height of 12. 6 cups, well, 6 times 2 is 12, plus 4 more is 16. Gives me the height of 16, and so on. Oops, there we go. So there are my 2 graphs. Are either the relationships proportional, and how do you know? Well, the answer to this is yes. And how do I know? And this is because, and it's the teacups. Teacups start at 0, 0, straight line, and they have a constant rate of change. All right. What do you think it means for a linear relationship to be proportional? Well, that's this right here. Is this, are my 3 rules. They have to be a straight line, constant rate of change, and it has to go through 0, 0. Go through the origin. All right. On the back. So for reminders of this lesson, consider these questions. What are the characteristics of a proportional relationship? And how can you identify a proportional relationship from a table, a graph, or an equation? All right. So Gilberto is going to be in a walkathon. He asks sponsors to pledge $2 for every kilometer he walks. He uses the table below to predict the amount of money he will earn for the charity. Okay. So if I walk to 0 miles, do you think I'm going to earn any money? No. Use the process column to examine the relationship between the distance and money. Is this proportional relationship, and how do you know? All right, so let's take a look. 0 miles, 0 money. So I'm told that for every kilometer he walks, he earns $2. So how do I get from 1 to 2? Okay, well, it looks like I can multiply by 2. Can I do 2 times 2 to get me to 4? Yeah. 3 kilometers times 2 is 6. 4 times 2 is 8, 5 times 2 is 10, 6 times 2 is 12, and 7 times 2 is 14. So is this a proportional relationship, and how do we know? Well, yes, it is a proportional relationship, and we know because we can multiply by 2 to every x value. Okay, so write an equation for the relationship between distance m and money m. So for every distance I'm going to multiply 2 to it. So I'm going to do 2d, and this is equal to the amount of money that I earn. Or you can write it as money is equal to 2D. Okay? So how much will Gilberto earn if he walks 12 kilometers? So if I'm going to walk 12 kilometers, I'm going to take 12, plug him in for D, so 2 times 12, and I'm going to get $24. All right. I have Emily and I have Henry. So Emily and Henry are in a race. Each table shows their distance from the starting line during the race. How fast is each brother walking? What's their walking rate in meters? Okay, so for 0 seconds, 0 meters. Okay, I'm going up by 10 here, and I'm going up by 25 here. Okay, looks like I'm increasing by 25 each time, and I'm increasing by 10 each time. So what I need to do is I need to see what is my rate that I'm going up by. So I'm going to do y over x. So for this brother, I don't have much room. We're going to have to do it right here. So 25 divided by 10. Okay, so I'm going to use my calculator. 25 divided by 10. I see that it's 2.5. So 10 times 2.5 should get me to 25. Is 20 times 2.5 50? It is. And it looks like Emil, or Emily, I know it's brother, so Emil, I think, 2.5 times that number. So each second, okay, so each second that I'm walking, I'm going 2.5 meters. Okay, so let's do this so we know Emil's. Okay, he's walking at a rate of 2.5 meters per 1 second. And then let's find Henry's. Well, wait. For 0 seconds, I'm starting at 45 meters. Okay, I'm starting at 45 meters. Okay, so let's take a look at the difference here. At 10 seconds, I'm at 55. At 20 seconds, I'm at 65. So wait, I'm going up by 10. I'm going up by 10. Well, to find my difference here, or not to find my unit rate, my slope, I had to take the y and divide the x. So I'm going to do the same thing here. Well, 10 divided by 10 is 1. Okay, well, 0 times 1 gets me 0. How do I get to 45? I add 45. Okay, well, 10 times 1 gets me 10. How do I get to 55? Well, 10 plus 45 gets me to 55. 20 times 1 plus 45 gets me to 65. 30 times 1 is 30 plus 45 gets me to 75. So it looks like for Henry, I have to multiply by 1 to every x that I have and then add 45 to it. Okay, so what was their walking rate in meters per second? Well, Henry, he was walking 1 meter per second with 45 meter head start. Okay, so what did you notice about each brother's distance at 0 meters? Well, at 0 meters here is 0 seconds. Well, Emil started at 0 seconds, 0 meters, while Henry started at 45 meters at 0 seconds. Okay. So use the process column to examine the relationship between their walking rates and their distances. Which brother's race represents a proportional relationship, and how do you know? Okay, so remember, to be proportional, I have to be a straight line, constant rate of change, and I have to go through the origin. So I have a constant rate of change for both of these. I'm multiplying by 1 here all the way down, and I'm multiplying by 2.5 here. But if I look, I have to start at the origin, so I have to start at 0 seconds at 0 meters, where Henry starts at 0 seconds at 45 meters. So which brother is proportional? And that's going to be Emil. Okay, and the reason for this is because he starts at 0, 0. Okay, he starts at 0, 0. What question is this proportion below trying to answer about Emil? Okay, so it shows my X value over my Y value. So time over distance. So it says for 20 seconds, I can go 50 meters. Well, if I'm going 300 meters, how many seconds is that going to be? So for this, it's saying for 20 seconds, he can go 50 meters. How many seconds can he do in 300 meters? That's the question they're trying to ask. Is that if for 50 meters I can do it in 20 seconds, how many seconds for 300 meters? Okay. So write an equation for the relationship below in D and T. Use the process column as your guide. Well, this is my process. This is what I'm doing. So remember our equation, D equals RT. Okay. Where R is the rate. That is my slope. That is my Y divided by my X. That is my rate at which I am going in my speed. So for Henry, okay, for Emil, I am going at a rate of 2.5 meters per second. So Emil is for every second he's going, he's going to multiply 2.5 by it to get to his distance. Okay. For Henry, he walks at a pace of 1 meter per second, but he started at 45 meters. So for Henry, he walks at a rate of 1 meter per second, but we have to account for the starting point of 45. So his equation is D equals 1t plus 45, or it's normally written as D equals t plus 45. Most of the time you'll see this because we do not write the 1 in front of the t. Okay, he's invisible. All right. Letter D. Miss Chang's class is ordering t-shirts and received cost equations from 2 different companies, Mighty T and No Shrink. Use the equations to complete the table for each company. So Mighty T is here and No Shrink is here. Okay, so for 10 shirts for Mighty T, it says to do C equals 49 plus, everywhere I see an N, that's the number of shirts. Okay, so N is equal to number of shirts. So 49 plus 10 is equal to 59. For 20 shirts, I have 49 plus 20 equals 69. C equals 49 plus 30 equals 79. And C equals 49 plus 40, which equals $89. Okay. For No Shrink, it's C equals 4.5 N. So for every shirt that I see that, I'm going to multiply it by 4.5. So C is equal to 4.5 times 10. C equals 4.5 times 20. C equals 4.5 times 30. C equals 4.5 times 40. So I'm going to do that. So 4.5 times 10, 45. 4.5 times 20, 90. 4.5 times 30, 135. 4.5 times 40, $180. So which company has a proportional relationship between the number of shirts and cost, and how do you know? Well, the one that I see that has a proportional relationship is my No Shrink. Okay, No Shrink. And how do I know? This is because at 0 shirts, it will cost $0. Versus Mighty T, if I had 0 shirts, I still have $49. Which, if you think about going to a t-shirt company, they're going to charge you a startup fee and then a price per shirt. Whereas No Shrink just says, here's the price per shirt, doesn't matter. Okay? All right, letter E. Identify proportional relationships. Tell whether each table represents a proportional relationship between X and Y. Okay, so first table, I see that X is 0 and Y is 4. Do we think this is going to be proportional or not? Well, the answer should be not proportional because when X is 0, Y has to be 0. Okay, well, let's take a look at this one. When X is 0, Y is 0. So is this proportional? Yes, this is proportional. Okay, so I'll multiply by 2.5. 2 times 2.5 gets me 5. 4 times 2.5 gets me 10. Okay, so the second one, I want to see, is this going to be proportional? Well, 1 times 6 is 6. 2 times 6 is 12. 3 times 6 is 18. 4 times 6 is 24. 5 times 6 is 30. And yes, this is proportional. Okay, so what do you notice about the ratios y over x for the tables of proportional and relationships above? Well, they, show that it's going to be proportional. Okay, and we just saw that right here. Number 2, tell whether each equation represents a proportional relationship between x and y. And then what do we notice about the equations of all proportional relationships? So, is this going to be proportional? Yes. Will this be proportional? No, because look, I'm starting at 20. Okay, I do not start at the origin. Will this be proportional? Yes. Will this be proportional? Answer is no on that one. Because, and here's why. If I look at this graph right here, it is telling me y equals 7. That means at the horizontal line of 7, I'm going to have a line that goes straight across, and that's it. I'm not going anywhere, so it's not going to be proportional. 1, it's not a straight line, or it's a straight line. But 1, it does not have a constant rate of change. It's not changing. And 2, it's not going through the origin. And then the last one, y equals x plus 12. Is this proportional? No, because I'm starting at 12. So what do we notice about the equations that are proportional, these two? They all look like this. So all look like y equals k times x, where k is your unit rate, constant proportionality, a number times x. They all look in this general format, okay? They all will start at 0, 0 at the origin. Okay. All right. Tell whether each graph represents a proportional relationship. Well, is this one a proportional? Yep. Is this one proportional? Nope. Is this one proportional? Look, it's a straight line, but it doesn't go through 0, 0, and it does not have a change, so no. Is this one proportional? Yes. Okay. So what do you notice about the graphs that are proportional? They are straight, constant change, and they all hit 0, 0. So what can we say about linear relationships? So a linear relationship is proportional if it is a straight line, has a constant rate of change, and goes through the origin. It is a straight line, has a constant rate of change, and it goes through the origin. If you guys have any questions, please let us